Solving system of inequalities. We're going to be graphing. Let's go. We're going to solve this first one, this first system, two equations, two unknowns, x and y. We're going to make a table. I make my table. I'm using red for the top inequality, blue for the bottom. So here's my table for the top one. I chose 0, -1, and 1 for the values I'm going to replace x with, and then solve for y on both. So having plugged in these values, I got the y values for the corresponding x value. Now I'm going to plot the points and draw my lines. So we plotted our lines. The red is a dashed line because y cannot equal 4x plus 2. It can only be greater than. The blue is solid because y can be less than or equal to. So I'm going to shade those in. And because this is a system of inequalities, we actually have a region where these are equal, and it's right in between here. It gets larger and larger as we continue to go to the left and go down. But what's saying is that any solution that falls in between, so underneath the line, y equals x minus 1, so y less than, and then anything above the line, y equals 4x plus 2, so that's why we shade it, because we have the inequality. So the point, -2, -4 is one that would satisfy both conditions. Also -3, -5, and any point in here on for infinity. Let's test -2 and -4. So I plugged those points in. Here's -4 for y. Here's -2. So it's -2, -4. Is -4 greater than 4 times -2, which is -8, plus 2 is -6. Is -4 bigger than -6? That is true, so that's good. Is -4 less than or equal to -3? That is also true, so this point is a solution. Now we're going to tackle a word problem. The student council is planning on sponsoring a college visit for a senior class. In order to transport everyone, they're going to rent vehicles. There's 155 seniors. They know at most there'll be 155 people going, so they're going to rent minivans and SUVs. Minivans can hold 6 people, SUVs can hold 4. So first, let's identify some variables. So we're going to write an inequality to model the situation. We're going to define the variables. So we identified them, now we must define them. So I said S is the number of SUVs they're going to rent, M is the number of minivans they're going to rent, and this is the equation that's going to tell us how many students are going or they can transport. 6 students per minivan, so that's 6 times M, plus 4 students per SUV, that's 4 times S. That number should be less than or equal to 155 because it says at most 155 people are going. They can take less, not everyone's going to go. Now we're looking at cost. They have a $600 budget. The minivan costs $22 each, and the SUV costs $18 each. We're going to write an inequality. We're going to use the same variable. And just for right now, I'm going to use units, so we know it's a separate equation from the one we just did. We're looking at total dollars spent. $22 per minivan plus $18 for SUV. We need to come at $600 or below. That's our budget. This is our max money that we can spend. We're going to go ahead and graph the inequalities. So I'm going to take a moment and label my coordinate plane and graph my lines. Okay, this graph is tough to see, but I have my axis. Each line represents the number of minivans and SUVs, the relationship to each other with cost and with number of students. So I have shaded under the green line some green highlighter. It goes all the way to here. And then under the yellow, there's a little bit there, and then the yellow line is below the green line. And so with it overlap, I shaded it in as blue. So any value in this space satisfies the 2 conditions where we can transport the number of students and also we stay under budget. So list one possible solution. I chose 16 SUVs and 8 minivans, okay? Because that point lies under both lines. So here's a question. Can the student council rent 40 SUVs? Well, in theory, they could. 40 would be enough. That's bigger than 155, so that actually it's 160 students they could transport. We need 5 fewer, so that's minus 1 more SUV, and you'd have an empty seat. But that's not really the question here. We can transport all 155 students with SUVs. Is it cost effective? No. With 40 SUVs at $18 a piece, that's $720. That is over budget. No, we cannot. This final question is saying, if everybody wants to go, can they? Can they go Do they have enough money to rent enough vehicles? Well, let's look at where these two lines intersect. They intersect right about there. And without zooming in and getting careful, it looks like it's 6 SUVs and 24 minivans. So let's double check. Okay, so the math works out. If we do 22 minivans and 6 SUVs, which looks like that's right about the spot where these lines start to cross. My drawing is very sloppy. There's 22 minivans and 6 SUVs. That gives us 156. So we actually have room, right? We only have 155 seniors, so we have an empty seat. So we're okay there. And then if we, at $22 for each minivan, $18 for each SUV, this gives us a total that comes in $8 under budget. So yes, we absolutely can.